So we're going to talk about angle relationships to start off our unit on trigonometry. We have three main things to talk about. All of these you've heard before. The danger is going to be that as soon as I say the words, you're going to shut down and think you get it all. And the problem is we have to marry what you learned in geometry with algebra. And if you shut down too quickly, you're going to be very confused more than likely. So just humor me and play along, like just watch what I'm doing and then see how we do it in problems. Definitely wait until you see the examples before you decide if you know it already. All right, so one kind of angle relationships we have to talk about are complementary angles and supplementary. So complementary angles add up to 90 degrees. And supplementary angles add up to 180 degrees. And that's it. That's an easy fact to learn, but as you're going to see, you have to be able to apply that, and we're going to be using variables now. They're not just going to all be numbers. Type of angle relationship 2 has to do with this. The sum of the angles in a triangle is 180 degrees. That is true for all triangles. You know that. You learned it in geometry. So if I have a triangle and I add this to this to this, that total has to be 180 degrees 100% of the time. The third angle relationships is going to be two parallel lines cut by a transversal. Now, I'm sure you learned a lot of things. I'm going to try to strip it down to this. Notice how I have acute angles and obtuse angles. See that? How one is small and one is big? If you look at how this breaks down, this transverse cuts it into 8 separate angles. And notice how I got this is acute, this is acute, this is acute, this is acute. Furthermore, this is obtuse, this is obtuse, this is obtuse, this is obtuse. Okay, a couple things are true here. One, all the acute angles are the same. 2, all the obtuse angles are the same. 3, if you look at them, any acute and any obtuse, when you put them together, see how that makes a straight line? So these two are supplementary. These two are supplementary. There are lots and lots of supplementary angles here. So remember, supplementary angles add up to 180 degrees. Now what that really means is 180 minus one of them gives you the other, or the acute plus the obtuse has to equal 180. So acute plus obtuse has to equal 180 degrees. Right? So those are the notes. That's what you need to work with. If that's a little small or hard to see, pause the video right now and you can zoom in and record whatever you want to record there. Take screenshots, whatever you want to do. I have to erase it now, so I'm going to do that. And I'm going to just run through some problems. What do I have? I have like 6 problems I'm going to do as examples, and then I'm going to give you homework that look a lot like similar but not exact to these 6 problems. Then for homework set number 2, I'm going to have a second little video where we're doing the same stuff but with story problems, right? So the next lesson will be, these are the notes for this lesson and the next one. Okay. So example problem number 1, let's say you're given this information. So look what I'm seeing. I didn't write numbers there. This angle is 3x plus 9 degrees. That's the best we can do. And look at how I'm going to ask the question. Find the angles. Now, what a lot of people do is they find x, and you need to find x. The problem is that's not your final answer. You have to be sure you answer the actual question. So I look at this, and you could go, I have no idea. And if you do have no idea, then you're not, the words that I just wrote, supplementary and complementary angles, are just words to you. You have to be able to apply them. Look at them. These two angles form a straight line when you put them together. That's what supplementary angles look like on a picture. That's what they look like. So this angle, whatever it is, plus this angle, whatever it is, has to equal 180 because they're supplementary angles. So look, I have one equation. I got to solve for x. That's true. Let's do it. 20x, that's 23x, plus 19 is 180. I'll take away the 19. 23x is 161. I'll divide by 23. And I'm getting 7. Now, because of your experience in high school math, you might want to stop and call it good, because x equals is always the answer to a math question. No, the question was find the angles. So now that I know what 7 is, I can plug that in, and angle 1 is 20 times 7 plus 10. So that would be 150. And the other one would be 3 times 7 plus 9. So 30. So these are the two angles. Notice that once I know what x is and I found them out, they do in fact add up to 180, just like they're supposed to. So this is a two-stepper. You got to use the fact about supplementary angles, you got to solve for x, and then you plug it in and get your answers. Okay? So I'm going to do the next example. These are all going to be very similar feel to them. So once you get the hang of it, it's not bad. So let's say I give you this picture, and I tell you that this is 5k plus 5 degrees, and this one is 3k plus 5 degrees. Well, when you put those two together, they form a right angle, or in other words, complementary. So 5k plus 5 plus 3k plus 5 has to add together to give me 90 degrees. These are like terms. These are like terms. Subtract 10. Divide by 8, and I get k equals 10. The problem is that's not the answer. I'm supposed to be finding the angles. So this one would be 5 times 10 plus 5, or 55 degrees. And 3 times 10 plus 5, or 35 degrees. And those do, in fact, add up to be 90 degrees. See, so there's complementary and supplementary angles, but they probably feel a little bit different than what you were thinking. Oh, here's one I didn't put in our list. Sorry, we got to add this to our list. There's something called vertical angles. Basically, whenever two lines cross, these ones that are across from each other, those are called vertical angles, and they're equal. So, if I tell you that this is 11x minus 37, and this is 7x plus 27, these are degrees, and I ask you to find the angle, this is what you're supposed to be thinking. All right, that's two lines crossing, so those are vertical angles. They're equal. So if you can think it, you can write it. They are equal. So then get the x's on one side. Get the numbers on the other. and divide by 4. And that gives me 16. You might want to say that that's the answer, but it's not. I'm asking you for the angle. So these are going to be the same. You could use either one you want. 7 times 16 plus 27 would be 112 plus 27. So that should be, my answer is 139 degrees. I'm just going to check that real quick. Yeah, that's right. Now, if I do this, it should be the same because these are the same. And if I do, this is actually what I just plugged into my calculator. I did get 139 degrees. Right? They're equal to each other. Okay, the next one was the triangles. So let's look at the triangles. What am I looking for? There's the basic one. So let's say that I tell you that this is x plus 15 degrees. This is x plus 5 degrees. And this right here on the inside is 10x minus 20 degrees. Well, you're supposed to realize that I don't care what they look like. When you add up angles, you get 180. So the first one plus, and you don't got to make, in fact, don't make that plus sign bigger. I'm just doing it so you can visually see one angle from another. But these are all regular size equal signs. So one angle plus another plus the third has to be 180. Now we're going to solve for x. X, 2x, 12x. 15, 20, that's 0. Divide by 12. And I think we're getting 15 there. Yep. That is not my answer, but I need it to get my answer. So if you want, when you're doing your homework, you can do it just like I'm doing it. So if x is 15, this is 20 degrees. This is 30 degrees. And you can actually subtract now if you want, but this would be 150 minus 20 is 130 degrees. Just something so I can tell, you knew what was what, and I can read it. Now we can take this and make it a little trickier. I know these examples drag out, but just think if this was class, we'd do a whole lot more in person. All right, so I've just extended this. Let's say that you know this angle, minus 8x plus 3, and you know this one is minus 5x. That's extra weird because it's got negatives in there. And now, instead of telling you this inside angle, I'm going to tell you this outside angle. Well, how am I supposed to do that? Because I don't know what that is. Well, this is a two-step equation, or problem. These are supplementary, right? In math, you can't just do one problem and then forget it exists and then do something else. You have to remember all of it. Even though it was just minutes ago, right, we still have to be able to apply it. So how do I do this? Let's just call this question mark for now. I don't know what it is, but I need it. So look, question mark plus 7 minus 12x. See how those make a straight line? That has to equal 180. So let's just solve for question mark. So I'm going to take away 7 for both sides and add 12x to both sides. That leaves me with question mark equals. Go figure. I wanted to know what question mark was. And this is going to be 173 plus 12x. That goes right here. 173 plus 12x. Now I can add these three angles together. Let's see, can you see? Yeah. Minus 5x plus a negative x plus 3 plus 173 plus 12x has to equal 180. Just be careful about that minus. Really, that's plus a negative, so I'm going to put a minus there. Right, so that's how it looks. This angle and this angle equals 180. So I have minus 23 plus 12 is minus 11x, plus 176 equals 180. Yep. And I'm going to move this over. Minus 11x equals plus 4. So x equals minus 4/11. That is very weird. I don't like it, but it's true. So now what do I got to do with that? Well, I got to plug it into each of these to get my angles. So let me get a little space here. I'm going to call this angle 1. That would be minus 8 times minus 4/11 plus 3. And I'm going to get a decimal here. So this is 5.91 degrees. This angle is 1.82 degrees. And that means this angle, oops, will be 168.64 degrees. Right? So that's this one, this is that one, and this is that one. And they might be yucky angles, but it all works out. So these should add up to be 180, very close. All right, so that just leaves us with our parallel lines one, and that'll go quick. This is the hardest problem that we had to deal with here. Okay. So we're going to cut those with the transversal. And let's say that I tell you 2x plus 61. And this is 6x minus 51. Well, whenever you're using parallel lines like this, you should look for acute and obtuse angles. Obtuse, 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 obtuse. Notice that these are both obtuse. Those are going to be equal to each other. These are all the acute ones, right? If one of them was obtuse and the other was acute, we'd have to handle this differently. We'd have to think about different facts. But in this case, these are the same. So how do I say things are the same in math? I say they're equal. So I'm going to solve. So I'm going to move the 2x over here. And I'm going to move the 51 over here. And I'll divide by 4. And I'm getting 28 degrees. So now I could punch that in and figure out my angle. And I should get the same answer for both. So 6 times 28 minus 51. That's 117 degrees. Just to make extra sure, 2 times 28 plus 61, also 117 degrees. Both obtuse, both the same. Alrighty, so I'm going to give you a few problems to try that are just like these out of your book. I'll send you a picture in case you were absent when I gave the book. And then our next lesson is going to be the same stuff with word problems, so we'll leave it there.